Good afternoon, I'm Luigi Sorrentino. I'm going to give you a short video presentation about unreinforced masonry building retrofit policy and effectiveness. This presentation was prepared with my colleagues Guido, Magenes and Andrea Penna from the University of Pavia. I am an assistant professor in structural engineering at Sapienza, University of Rome, and my main research interests are in the earthquake performance of masonry structures. The Central Italy earthquake has shown a tremendous impact on unreinforced masonry buildings, as you have seen from the previous presentations. However, we can also observe a dramatic difference in the performance among adjacent buildings. In this slide, with pictures taken in the Corso Umberto I, the main street in Amatrice, you can see completely collapsed buildings close by buildings which are still standing. And these buildings display wall anchors which are attached to steel tie rods. So for sure this type of intervention can be recommended and can have a positive effect on these structures. If we move to Norcia, where the overall performance of the buildings has been much better, we can observe the systematic use of wall anchor and steel ties. These elements are not just the result of recent earthquakes and following retrofittings, are the effect of at least a 19th century event which caused more than 100 deaths in Norcia. Following this earthquake, one among the first building codes for earthquake-resistant constructions was issued. This standard limited the number of stories at 2 and set a limitation also to the overall height of the building. Similarly, it recommended minimum thickness for the walls and a tapered section along the height. All elements which we are able to observe still today in Norcia. At the same time, strong emphasis was put about the quality of the masonry, with recommendation of use hydrated lime and sand washed with fresh water, with the ban on round stones and the recommendation of fired clay bricks or semi-dressed limestone units. Moreover, there was the recommendation to connect horizontal structures to vertical walls and to resort to wall ties. If we observe some buildings in and around Amatrice, we are able to recognize the use of wall anchors and steel tie rods. However, we see an unsatisfactory performance. This performance is related to the very poor quality of the masonry, which has already been highlighted in a previous presentation, both due to the mud mortar and to use of round stones. Therefore, if the mortar quality is so low, even a systematic use of steel ties is not sufficient. In this other building, which was the Carabinieri, so a police station in Amatrice, which was undergoing a retrofitting intervention following the L'Aquila earthquake at the time of the August earthquake, we are able to see a systematic intervention with steel stitches. This intervention, coupled with the top steel tie rods, saved the building from the collapse, but such a building would not be operational after an earthquake, as it is expected for a strategic building like a police station, and this is an example of the limited improvement that can be expected from a poor masonry building even after systematic interventions. Another critical point is that of the top bond beams. These bond beams have been built using reinforced concrete elements, and in the past the poor performance of the buildings displaying this type of beams was related to the lack of a connection to the below standing masonry. However, we can see in this slide two examples of shear connectors at the center of the wall section or on the two external leaves of the wall sections, which performed unsatisfactorily. However, also if still top ring beams are used as recommended more recently, we observed poor performance irrespective of the use of a top element on the top face of the wall or on the side of the wall close to the top, despite in this case on the right a very systematic connection through bolted bars. Therefore, again, the quality of the masonry becomes crucial, and this comment applies also to the use of reinforced concrete roofs as a retrofitting intervention. We have seen pancake collapses, which are certainly associated to this type of intervention. However, we can also observe buildings where the performance is much better, even if such a stiff and heavy element is adopted. And the reason for such strong differences in the performances is again the quality of the masonry. Matter of fact, if we observe buildings still possessing their timber roofs, we see that despite the use of very light elements at the top of the building, we have a collapse of the walls because the quality of the masonry is again insufficient. Among the intervention that seems to have worked on the original masonry, there is the repointing. So this technique, which recommends the removal of the original mortar from the external leaves and its replacement with a more adequate mortar. In these two examples, we see that the building behaved in a reasonable way on the left, in a very good way on the right. However, we don't know if additional interventions, so for example injections of mortar mixes, have been carried out at the same time. Another intervention to improve the masonry performance is the so-called reinforced concrete coating, so plastering the wall with reinforced plaster where the reinforcement is a welded mesh. When this intervention is carried out just on the inside, the performance is usually inadequate, whereas if the intervention is carried out on both sides, we see a much better performance. In this other case, we are in front of a building which in the mid-80s was demolished, and its stone units have been used to build a new one with a modern mortar. At the same time, reinforced concrete ring beam, both at floor levels and at window opening, were introduced, and the performance was very, very good indeed. This building is in Castelluccio di Norcia, was again completely rebuilt. Here on the left you have the Google Street View 2011 screenshot, whereas on the right you have the building as it appeared last September, and you can see that there is no damage in the building, but at the same time there is no sign of any wall anchor. This is because the stonework is just a cladding, and the actual structure of the building visible from this hall is that of a modern mason with hollow clay blocks. The stone cladding was then connected to the structural masonry through these rebars. However, this kind of intervention, which was very effective from a structural point of view and is able to save the ambient appearance of this historical center, can be called into questions by architectural restorers. And there are some issues about the durability of these rebars unless stainless steel elements are not used. I would like to thank you for your attention and leave the stage for the next speaker.